Okay, so in this video today I'm going to do two things: symmetry properties, which is really short. It looks very confusing with the notation, but it will just be three little things to have a look at, and then the Pythagorean identity, which you are given on your formula sheet when you come across that. So the first thing is these symmetry properties, which are often called complementary relationships. And all it's doing is a little bit the opposite of what we usually do. So when I normally draw my unit circle, and let's just say this is 30 degrees, and if I wanted cos of 30 degrees, I know that that is equivalent in quadrant 2, if this is 30 away. So cos of 180 minus 30, or what would be cos 150, will be the same as whatever it is in quadrant 1, except it's going to be a negative. It's going to be negative of whatever cos 30 is, because in that quadrant, cos is negative, only sine is positive. And I can complete this diagram. I can do quadrant 3, quadrant 4. So I'm always putting the angle back to the x-axis. So these angles here are from the x-axis. So it can just be whatever it is in quadrant 1, you just have to identify if it's positive or negative. So if I did cos of 180 plus an extra 30 to put it into quadrant 3, that would be cos of 210. But if I know what it is in quadrant 1, I just have to make it negative cos 30. And similarly, if it went into quadrant 4, so 360, if I take off the 30, and I just had cos of 330 degrees, it's the exact same x-coordinate of what it is in quadrant 1. So I can relate everything back to quadrant 1, it's either positive or negative. Now, I've just said that this is taking an angle back to the x-axis. So what if the angle they're giving you is to the y-axis? Well, all you're going to do is switch your sine and cos. So over at the side here, this is saying sine of pi on 2 minus theta. The way this notation is written, pi on 2 minus theta means that we're just in quadrant 1, where sine is positive anyway. But because they've taken the angle back to the y-axis, so pi on 2, let me get a different colour here. So pi on 2 is up here, and then if you subtract theta, it's actually giving you an angle in here. So instead of giving it to the x-axis, it's the y. So all you need to do is swap your sine and cos. So in that quadrant, sine's positive, so it'll be cos theta. If I come down to this next one down here, cos of pi on 2 minus theta. Pi on 2 minus theta, we've just said, well, that's something that's in quadrant 1 where cos is positive anyway. So it will just be sine of that angle theta. Going further down, this next one, sine of pi on 2 plus theta. This is putting something into quadrant 2. So in quadrant 2, sine, that's what they're asking for, is positive. So we're going to switch it to cos. It'll just be cos of this angle theta. But I don't need to make it negative because sine is positive in quadrant 2. Whereas with the next one, cos of pi on 2 plus theta, again, this is quadrant 2, but in quadrant 2, cos is negative. So I'm just going to use this angle theta, but it'll be negative sine theta. So I swap the cos with the sine, and you just have to allow if it's positive or negative. So let me do some examples and see if that makes it any clearer at all. So in example 26, you've got if sine theta equals 0.3, cos alpha is 0.8. So really that's just telling me in quadrant 1, if I was to take sine of angle theta, which is your y-coordinate of theta, that value is 0.3. And they're telling me that cos of alpha, wherever alpha happens to be, I have no idea where that is, but its x-coordinate is 0.8. I don't really need that diagram, but that's what they're giving me. So in A, we've got sine of pi on 2 minus alpha. So all I'm going to say to myself, where is pi on 2 minus alpha? So pi on 2 is up here on the y-axis. If I subtract alpha, then I'm in quadrant 1. So I want my answer to be a positive answer. And because the angle here is back to the y-axis, it tells me I switch my sine and cos and just go with this little angle alpha. But I know what cos alpha is. Cos alpha is 0.8. So my answer is positive 0.8. And that's it. That's all I'm doing. In part B, we've got cos of pi on 2 plus theta. So I'm going to have a think about where that graph would be. Pi on 2 is up on the y-axis. When you add theta, you go that little bit extra around. It's in quadrant 2. Now they've asked for cos. In that quadrant, cos is negative. And now all I need to do, because the angle is back to the y-axis, is switch your cos with your sine and just use this angle that they've got, which is the theta. In the question, they told me sine theta was 0.3. So this is negative 0.3. And the final one is sine of negative theta. So for sine negative theta, let's think about where the graph would be. Negative just means you go in the opposite direction. So, sorry, negative alpha, I should say. Negative alpha puts it in quadrant 4. Sine is going to be negative in that quadrant. So it's going to be negative. And this is an angle back to the x-axis. So it's still going to be sine alpha, but it's just going to be negative in that particular quadrant. So this is an angle back to the x-axis. You don't switch sine and cos when the angle is to the x-axis. Only in like A and B where it's to the y-axis. And sine alpha in the question, did we have it? Oh, I've copied it incorrectly. It was theta. Bear with me. I had a mistake there. This is angle theta. So if you're wondering what I'm doing, I made an error. So sine theta, I do have that. That's negative 0.3. And that's my solution. What I've just covered in these 3 examples, it's not the main focus of what we're doing in this topic. And to be honest with you, the only time I've come across this since teaching it, so with the current year 12 methods class, they've just come across it in their revision, looking back at units 3 and 4. So they've had to look at a couple of questions that they had to simplify, but honestly, the rest of the time you hardly have to use this. But just keep in mind, if you're doing an angle back to the y-axis, you need to switch your sine and your cos ratios around. Okay, other than that, we treat it the same. In the next one, the Pythagorean identity, this is the formula. Okay, so we have that cos squared of some angle plus sine squared of the same angle equals 1. And that rule is given to you on your formula sheet, and it holds for anything. The only thing I want you to make a note of, and I'm just going to put this at the side and maybe you could copy this down. The note is that if you have sine theta all squared, we write it as sine squared theta. We usually put the little squared in there. If the whole thing is being squared, it is not equal to sine of an angle squared. That's very different. You would need to have it in a bracket. And the same thing with cos squared theta. So just note that if you have cos squared theta, keep in mind that it means that cos theta is all squared. Okay? So if you are adding sine squared theta and cos squared theta, you get this value of 1. I'm going to jump straight into the first question and show you how to solve that. So in part A, the first thing they've given us is that sine of some angle gives 3/5. And the value of x, the angle, lies between 90 and 180 degrees because it says pi on 2 and pi. So in part A, we've got cos x that we need to find. All they've given us is sine x. Cos x equals, don't know. So what I am going to start with is the Pythagorean identity, because that's something that links cos and sine. So the Pythagorean identity is that cos squared, and you don't have to use theta. In this question they're using x, so let's use x, plus sine squared x equals 1. I'm going to substitute sine x equals 3/5 into this equation. So I don't know cos squared x. I want to find cos x though. Sine of x is 3/5. But in this rule, you've got to square whatever sine x is. So it becomes 3/5 all squared. And if I just rearrange this and then move the 9 on 25 to the other side, I can start to solve for cos x. So I'll just finish this one. So cos x, is going to equal the square root of what we've got left over, 16 on 25. And that's going to work out to be plus or minus, don't forget. Okay, so I need to keep finishing from here. So I know that they've told me that x has to lie between, but x lies between 90, or pi on 2, and pi, which tells me that x is going to be in quadrant 2. And in quadrant 2, cos is going to be negative, so x just needs to be the negative value. X is negative. So my answer for cos x, I'm going to leave it as a fraction because the question told me that sin x was a fraction, so let's leave it as a fraction. Cos x is negative 4/5. Okay, and that's my answer. And then in part B, you can just use your answer that you found in part A. So I'm going to come over here. So for part B, tan x is sin x over cos x. We've already worked these answers out, so I'm just going to put a note here. Use answer to part A, and let's just sub in what we know. So sin x was in the question, that was 3/5, so we've got 3/5, and we're dividing by cos x, which is negative 4/5. Now you can't divide by fractions, but you can times by the reciprocal. So the 4/5 flips to 5/4. So multiply by reciprocal, and that means that we end up with negative 15 on 20, and that cancels down to negative 3/4 if you cancel down the fractions. So therefore the answer for tan x equals to negative 3/4, and that makes sense. They said that x was in quadrant 2, and tan is also negative in quadrant 2. All right. So this little summary at the bottom of the page, just keep in mind when they put pi on 2 minus theta, this bit here, this is telling me we're in quadrant 1. Just fancy way of writing it. If you do 90 plus pi, this is going to put you in quadrant 2. And just keep that in mind. So it depends what quadrant you're in, if you're positive or negative. And then your Pythagorean identities down the bottom. Okay, so there's some questions there to try. I think this probably needs to be questions 1 to 5. There's not many of them. And in question 1, maybe just pick 3 to do out of the whole list that they've given you there. I think they've given you 10. So maybe just pick a couple. All right, any questions? Let me know.